Welcome back, folks, to Precalculus. Today we're in Chapter 3, Section 2, talking about polynomial division. Okay, so polynomials are very similar to real numbers in that we can take one polynomial and divide it by another polynomial, just like we can take one real number, divide it by another real number, and get an answer. Okay, so here, when we talk about dividing polynomials, in this little definition here, which will make more sense as we do more examples, the d of x is called the divisor. Okay, what you're dividing a polynomial by. Q of x is called the quotient, or what you get, the answer. And R of x is called the remainder. You probably remember that from the first time you did division. Sometimes we'll have remainders, sometimes we won't. And when we don't have them, it'll be especially good and beneficial. So let's just review some really quick old school division. So let's take 1,751 and divide it by 2. Okay, so if we review here that 2 does not go into 1, but 2 goes into 17 8 times. And then we take 2 times 8, and we get 16, and we subtract. So we get 1. Now we reevaluate, and 2 doesn't go into 1, so we bring down the next number. 2 goes into 15 7 times. 2 times 7 is 14. You subtract again, you get 1. Once again, 2 does not go into 1, so we bring down the last one all the way up here. 2 goes into 11, 5 times, so that's 10. Subtract, you get 1. Sometimes you maybe remember writing R1. Proper way is 875 plus your remainder divided by your divisor. Okay, so now let's apply that to a long division of polynomials here. So here we see we have polynomials, no division of variables, no variables underneath radicals or anything. So we can long divide. And I like to relate this to mowing a yard, which will make sense here in a second. But first we want to write it all out using placeholders if we need to. Notice I don't have an x squared term, so I'm going to throw it in there, 0x squared minus 8x plus 3. Okay, so what we're looking at here is we want to get rid of this. I want to mow the yard and get rid of this column first. Okay, so what do I need to multiply 2x by in order to get 4x to the 4th? Well, I need to multiply it by 2x cubed. 2x times 2x cubed is 4x to the 4th. And negative 3 times 2x cubed is negative 6x cubed. And we're going to subtract. And if you do things properly, when you go to subtract, you should mow the yard. That row should disappear. It's like cutting the grass. Now 2x cubed minus negative 6x cubed, so that's like adding. It's the most common mistake people will make in this stuff, is 8x cubed. And then let's go ahead and bring down our next term. Okay, so now let's get rid of this column right here. So what do we need to multiply 2x by in order to get 8x cubed? We better multiply by positive 4x squared. And when 2x times 4x squared equals 8x cubed, negative 3 times 4x squared is negative 12x squared. And we can subtract, and we should notice now the yard being mowed. That's good stuff. 0 minus negative 12 is going to be a positive 12x squared. And bring down your next term. Notice it's just rinse and repeat over and over again. So here, 2x times what equals 12x squared? 6x. 2x times 6x equals 12x squared. Negative 3 times 6x equals negative 18x. And we subtract. Look what we got here. Let's go ahead and mow the yard. 12x squared minus 12x squared is 0. Negative 8x minus negative 18x, so that'll be like adding, is going to be 10x. And let's bring down our last term. What do we need to multiply 2x by in order to get 10x? Well, you know that's 5. 2x times 5 is 10x. Negative 3 times 5 is negative 15. We subtract. And this column is gonzo garbanzo. 3 minus negative 15 is going to be 18. 2x does not go into 18, so 18 is our remainder. We can write it as plus 18 over 2x minus 3. Okay, so let's talk a little bit about a quicker version of dividing polynomials, and that's synthetic division. Okay, synthetic division implies, it simulates long division process, but condenses it and makes it more efficient, but only when the divisor is monic linear. Basically meaning that the x is to the first power and the variable in front of the x is 1, just like you see right here. Okay, see how we're dividing by x plus 3? It's linear because the degree is 1. It's monic because the leading coefficient is 1. So when we synthetic divide, you might remember setting this up. The number that goes on the outside is the 0 of the divisor. So here, x plus 3, so the 0 would be negative 3. Then on the inside, we just put our coefficients, remembering to use placeholders again if we miss a term. So here we have a negative 2, a 0 for the x cubed column, an 18, a negative 6, and a 2. So synthetic division is super simple. Just to review it one time, and then we'll go fast from here on out. You bring the first term down, no matter what it is. You multiply negative 3 times negative 2, you get 6. And then in synthetic division, you add 6. And then you just rinse and repeat. Negative 3 times 6, negative 18, add. Negative 3 times 0, add. Negative 3 times negative 6, add. And what this gives you is the division of this polynomial by x plus 3 is equal to this polynomial right here. And because you're dividing by x to the first power and you started with x to the fourth power, this first term is going to be x to the third power plus 6x squared. 0x, we don't need to write it, minus 6 plus 20 as our remainder over x plus 3. Okay, let's talk a little bit now about the remainder theorem. So if a polynomial is divided by some factor x minus c, using synthetic division, monic linear, then we know that the remainder is going to be equal to p of c. Basically, we could plug in our c value into our polynomial and get the remainder instantly. But first, let's do synthetic division to prove that. Okay, so here we have a polynomial. I'm going to do synthetic division. I got monic linear division, so I'm going to divide by 2. My coefficient, negative 5, 3, 5, 2. And we're going quick here. Make sure I'm doing that right. 2 times negative 5 is negative 10, plus 3 is negative 7, times 2 is negative 14. That would be negative 9, that would be negative 18, and this should be negative 16. So there's our remainder, negative 16 over x minus 2. So if we evaluate p of 2, we should get negative 16, which is the remainder. So let's go ahead and do that. Let's find out what negative 5 times 2 cubed plus 3 times 2 squared plus 5 times 2 plus 2 is. So this would be negative 40. This would be 3 times 4 would be 12. This would be 10, and that is 2. Negative 40 plus 12 is negative 28. Negative 18 plus 2 is negative 16. There's the proof of the remainder theorem that this number is going to match this number as long as you plug in the c value into your polynomial. So pretty cool little functionality of the remainder theorem, and you'll see the functionality more of it as we go through the chapter. Okay, now let's talk a little bit about the factor theorem. So we've always wanted to be faster at factoring polynomials. Well, if P of C, meaning you plug a value into a polynomial and you get out 0, and that automatically tells you that x minus that value is a factor. In backwards logic as well, if x minus that value is a factor, then when you plug in that C value, you should get out 0. Okay, so let's go ahead and let's just plug in 1 into our function here. Let's see what happens when we plug in 1. We're dividing it by x minus 1. We want to know, is x minus 1 a factor? When we plug in 1, we should get out 0. So 1 cubed minus 5 times 1 squared plus 2 times 1 minus 2. So we've got 1 minus 5 plus 2 minus 2. Those are gone. Get negative 4. Let me just triple check my algebra here. Squared, beautiful, 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 beautiful. Not a factor. Not a factor. We can double check that by doing synthetic division. Let's go ahead and do synthetic division with the value 1. So 1, negative 5, 2, negative 2, bring the 1 down. 1 times 1 is 1. That'd be negative 4, negative 4, negative 2, negative 2, negative 4. There you go again. Not a factor. Okay? The only way it's going to be a factor is if you get a 0 remainder. That would mean that this divides evenly into our polynomial. 0 remainder is going to be the magic buzzword. Okay, now let's go backwards from finding zeros. We've got 2 more examples, people. You guys are doing great. Let's go backwards from finding the zeros. We know the zeros now to building a function. Okay, so if we know that 2 is a 0 of a function, that means that x minus 2 is a factor. That means that somewhere along the lines we used the zero product property and x minus 2 was a factor. We set it equal to 0, we solved, and we got 2. Okay, now looking at this, plus or minus radical 5. Now you might think, oh, x minus radical 5 and x plus radical 5 have to be factors. But if you're just a clever-witted cat and you just take a closer look at this, you're like, oh, well, that means I had to square root something. That means that eventually, somewhere along the line, we use the zero product property, and x squared minus 5 was set equal to 0. Because if x squared minus 5 is equal to 0, x squared equals 5, x equals plus or minus radical 5. So we know these are our 2 factors. Now just foiling them to make a new polynomial is easy peasy. X times x squared is x cubed minus 2x squared minus 5x plus 10. And there's your polynomial. Okay, last example of the day. Last example of the day, we're dealing with a 4th degree polynomial. We're being asked to find all the other zeros given that negative 4 is 0. Now, if we recall, the fundamental theorem of algebra says 4th degree polynomial, we should be getting 4 zeros. So here we go. We know that negative 4 is a 0, so we automatically know that x plus 4 is a factor by the factor theorem. And because that's a factor and that's a 0, we know we can use synthetic division. So let's go ahead and do synthetic division with our 0. Negative 4, 1, 5, negative 5, negative 45, and negative 36. Okay, so quick synthetic division, bring the 1 down, negative 4, 1, negative 4, negative 9, 36, negative 9, 36, 0. Okay, awesome. We got a 0 remainder. That tells us that the problem was not lying to us. Negative 4 is a 0. So what this tells us is that this polynomial right here is actually equal to be factored, x plus 4 times this whole thing. X cubed plus x squared minus 9x minus 9. So now it's just a matter of, do we know how to factor this? And I'll bet you guys remember how to group. So let's go ahead and group. Don't forget about your x plus 4. Let's factor off an x squared. Leaves us with an x plus 1. And then minus 9 leaves us with an x plus 1. And we can factor off that x plus 1. And it leaves us with an x squared minus 9. I bet right now you're getting really shaky pencils because you recognize that x squared minus 9 is the difference of squares. And can be factored into binomial conjugates. And there we go. And if we want to find all the zeros, set it equal to 0 and apply the zero product property. So we already knew negative 4. Now we see negative 1. Now we see negative 3 and 3. There's our 4 zeros. Answers to your polynomial. Please bring those questions to class. No need to do the 2 examples on the back, and I look forward to helping you.